Everything you know about the moon is a lie. For all of human history, it kept showing Earth the same face and letting familiarity pass for understanding. That was the trap we all fell for. It made us confuse recognition with understanding. But the moon we thought we knew was only one side of the object. Half a world locked in place by gravity, keeping the rest turned away in permanent refusal. And when that hidden half finally came into view, it did not add a few missing details to an already complete picture. It broke the picture. Stay with me, because the other side of the moon is not what most people think it is. And if you enjoy deep dives into strange worlds and the most extreme places in the cosmos, consider subscribing. It genuinely helps the channel. Now settle in, because this story gets much stranger from here.
The far side was not the moon people had imagined waiting just out of sight. It looked less like the moon in our heads and more like evidence that our confidence had been premature. The real shock is not that the moon has a hidden side, but that the hidden side changed what the moon is. It suggested that the moon is not one simple, evenly written world, but a body divided by deep asymmetry. One side was extensively resurfaced, the other was not. One side had been rewritten often enough to become familiar. The other kept much more of the older damage visible. And once that became clear, the moon stopped feeling like a simple body with one uniform geological story.
It became a reconstruction problem. Once you see that split clearly, the moon stops feeling settled. The reason we see only one face is well understood. Over immense spans of time, Earth's gravity slowed the moon's early rotation until its spin matched its orbit. That state is called tidal locking, but the phrase sounds tidier than the process was. It was not a switch. It was a long gravitational negotiation, a transfer of energy, a steady draining away of rotational freedom until the moon became fixed in this relationship with Earth. One hemisphere turned toward us, one turned away. The result feels natural now only because it has lasted longer than human memory. But tidal locking did more than high terrain. It shaped our psychology. It made the moon feel legible before it actually was. You can build myths around a face you keep seeing. You can map it, name it.
Turn its dark patches into a man, a rabbit, a warning, a companion. Familiarity expands fast when an object repeats itself. Knowledge does not. For most of human history, the unseen half of the moon was not a mystery we could solve. It was simply absent, and absence has a way of being mistaken for simplicity. Then, in 1959, that ended. The Soviet spacecraft Luna 3 swung around the moon and photographed the far side for the first time. The images were crude by modern standards, blurred and difficult, but they were enough. Enough to show that the old assumption had collapsed. The hidden hemisphere was not just a rotated version of the face everyone knew. The great dark maria that dominate the near side were mostly absent. The far side looked harsher, more cratered, more heavily scarred. The moon had not been hiding a duplicate, it had been hiding an asymmetry.
The dark areas on the near side are not just markings, they are maria, enormous basalt plains formed when ancient volcanic eruptions flooded huge impact basins with lava. They are why the moon looks the way it does from Earth. Without them, it would be a different object in human imagination. The far side has some maria too, but far fewer, and they cover much less area. Instead, the far side is dominated by highlands, brighter, rougher, thicker crusted terrain saturated with craters. It preserves the look of a world that endured impact after impact without being rewritten nearly as often by later volcanism. So the question stopped being, what is on the far side? The real question became, why are the two sides so different at all? That is where the moon gets difficult, because this is not just a matter of one side getting hit more often. The pattern runs deeper.
Measurements over time showed that the lunar crust is not uniform. The far side, on average, has a thicker crust than the near side. That difference is enormous. If giant impacts punched into both hemispheres early on, lava would have found it easier to break through thinner crust on the near side. Thin crust means easier eruption. Easier eruption means more flooding of giant basins. More flooding means more maria, more resurfacing, and a face that looks darker and smoother from Earth. A thicker far side crust would have resisted that process. Large basins could form there too, but fewer would be buried under later lava. The scars would remain exposed. The surface would keep more of its older history. So the moon we thought we knew was, in a very real sense, the geologically edited version. The near side was not spared violence.
It may actually advertise violence more seductively because the basalt plains are themselves consequences of colossal impacts. Vast basins formed. Heat and fractures opened paths upward. Lava rose and spread. The dark patches we know so well are not marks of calm. They are the cooled remains of ancient planetary-scale damage. We call them seas, maria, because early observers mistook them for oceans. Even their name is a fossil of misunderstanding. The smoothness that made them seem gentle was born from catastrophe. The far side kept fewer of those dark coverings, and because of that, it can look more brutally honest. Crater lies over crater. Highlands dominate. The surface appears older not because time passed differently there, but because fewer later events reset the visible record. In that sense, the far side can feel like a less edited draft of lunar history.
And that leads to the deeper question. Why was one side rewritten more than the other? Several explanations compete here, and none closes the case completely. One major idea points to conditions very early in the moon's life, possibly when it still had a global magma ocean. The moon likely formed in the aftermath of an enormous collision between the young Earth and another large body. Out of the debris, the moon assembled, hot, molten, and evolving fast. In that state, internal materials separated, cooled, and crystallized. If heat was distributed unevenly during that era, or if the moon's orientation relative to a still hot Earth affected how quickly different hemispheres cooled, then one side could have developed a different crustal thickness from the other. The far side may have ended up with more crust-building material accumulating early, producing a thicker outer shell. That would have set the stage for everything that followed. In some versions of this picture, Earth itself becomes part of the explanation.
The young Earth, still blazing after the giant impact, may have radiated intense heat on the hemisphere of the moon facing it. That would not mean the near side was simply cooked while the far side chilled in darkness. The system was more complicated than that. But even moderate differences in thermal environment, acting on a molten or partially molten moon, could have affected where certain minerals crystallized and how the crust built up. Over enough time, a small early imbalance could become a lasting structural asymmetry. Other ideas emphasize impacts more strongly. Maybe giant basin-forming collisions altered the moon in ways that amplified existing differences. A large impact does not only excavate a hole, it redistributes heat, fractures crust, changes local thickness, and creates conditions that can influence later volcanism. If the near side experienced a sequence of especially important basin-forming events under the right conditions, it might have become the easier place for magma to rise. Once that process starts, asymmetry can reinforce itself.
More eruptions create more thermal and structural differences, which can make later differences even easier to sustain. Then there is the possibility that what we are seeing is not the result of a single clean cause at all. That is often less satisfying, but more realistic. The moon may have inherited some asymmetry from formation, modified it through thermal evolution, exaggerated it through giant impacts, and then locked it in place through differences in volcanic resurfacing. In other words, the split face of the moon may be a compounded history, not a one-line explanation. That is usually how real worlds work. They do not preserve one event, they preserve sequences, and the moon keeps supplying evidence that its history is layered. Later missions mapped topography, gravity, composition, crustal thickness, and hidden structures in far greater detail than Luna 3 ever could. What emerged was not a tidy correction to the first surprise, but a deepening one.
The far side is not merely heavily cratered. It is compositionally and structurally distinct in ways that connect surface appearance to deep interior history. Some regions suggest immense ancient impacts, with consequences still readable in gravity data and crustal architecture. Massive basins, including the South Pole Aitken Basin on the far side, point to collisions so large they rank among the most extreme in the solar system. That basin alone is a reminder that the Moon's quiet appearance from Earth is an observational trick. Up close, lunar history is not serene, it is catastrophic. The South Pole Aitken Basin deserves a pause because it changes scale. This is not a modest crater. It is a colossal scar, thousands of kilometers across, probably formed very early, and powerful enough to expose material from deep within the Moon.
Features like that are not background decoration. They are access points into the Moon's internal history. They tell us that the far side did not merely avoid change. It endured overwhelming change, then preserved more of the evidence in visible form. And that preservation may be exactly why the far side feels so unsettling. It denies the neat version of the Moon. The near side trained us to think in broad, dark shapes and relative simplicity. The far side offers saturation, fracture, density, damage. It looks like a place where history piled up faster than geology could erase it. The old familiar Moon was never false exactly. It was partial. And partial truths are often the hardest ones to unlearn because they come wrapped in repetition. But the far side matters for another reason too. The Moon is not just a nearby object, it is a record. Because it lacks thick air, active weather, and Earth-like plate tectonics, its surface can preserve events for immense spans of time.
That makes lunar asymmetry more than a visual curiosity. It is a surviving archive of the early solar system, of bombardment, internal heat, crust formation, and planetary aftermath. If the far side really preserves older or less overprinted terrain, then the Moon's split personality is not an inconvenience for science. It is the opportunity. Two hemispheres, two preservation styles, two ways of reading one ancient world. And yet the case remains unfinished. That is important. The mystery of the Moon's two faces has not dissolved into a single universally satisfying answer. Models improve, data sharpens, certain ideas gain weight, others weaken, but the full chain that links formation, crustal asymmetry, giant impacts, heat flow, and volcanic flooding is still being reconstructed. The Moon is close, it is constantly photographed, it has been visited, sampled, mapped, orbited, and measured.
And still, one of its most obvious features, the fact that its two hemispheres do not match, opens into questions that are larger than the Moon itself. Questions about how rocky bodies cool, how early conditions can leave permanent imbalances, how much of planetary history survives, and where. That is the deeper reason the Moon feels stranger the closer you look. Not because every answer vanishes, but because the answers lead downward into older causes. The familiar disk above Earth is the visible top layer of a much older process. The Moon looks simple at a distance because distance hides asymmetry well. Earth spent too long staring at one side and mistook repetition for completion. Familiarity, in other words, did not come from completeness, it came from angle. That mistake is understandable, maybe inevitable. The Moon is the easiest celestial object to think we have finished with. It is nearby.
It is iconic. Its cycles are obvious. Its face is memorized before most people know what Maria are. It does not glitter with the chaos of Jupiter or the rings of Saturn or the weather of Neptune. It seems done, resolved, filed away in the mind as a known object. But it is not resolved. It is a divided archive orbiting overhead. A world whose most familiar appearance depends on resurfaced damage. A body that taught us, very quietly, that seeing only half the evidence is enough to distort the whole picture. The Moon had not become stranger because it changed suddenly. It became stranger because our viewpoint finally improved enough to break the older, smaller image. That may be the most enduring lesson of the far side. Discovery is not always about finding something completely alien. Sometimes it is about realizing that the familiar object was never familiar on honest terms.
The moon did not deceive us. Gravity arranged the view.
History arranged the surface. We supplied the certainty. And once that certainty breaks, the moon changes. Not visually, perhaps. It is still beautiful. Still cold light over rooftops and fields. Still the same near-side patterns that humans have mapped onto stories for thousands of years. But behind that face now sits another one, brighter, harsher, older, less forgiving, and essential to the truth. Together, they make the moon feel larger than its size, not because it became larger, but because our understanding did. So the next time the moon looks calm, remember what that calm depends on: a locked orientation, a selective view. A hemisphere shaped by ancient impacts and lava floods that made catastrophe look smooth. And beyond it, a second face that kept more of the damage visible. We thought we knew the moon because it stayed familiar. What we really knew was the side that familiarity allowed. The moon was never simple, only familiar from a distance.
The moon may be the most familiar object in the night sky, but familiarity is not the same as understanding. Thanks for watching. Subscribe to our channel for the next one.